Welcome to the third series of this session, and it will be speaking about moles and with respect to the empirical formula. So the empirical formula of a compound is the simplest whole number ratio of atoms of each element. It is determined using the data from experiments, and therefore it is an empirical formula. For example, if you have glucose, okay, C6H12O6, its empirical formula will be CH2O, which is the empirical formula. Okay, and this is because 6 divides all the numbers in glucose. Okay, so 6 is divisible by 6, 12 is divisible by 6, and 6 for oxygen is also divisible by 6. So we can divide everything by 6 to get the empirical formula. So how do we find the empirical formula? What you do is you write elements up here. So we can write, for example, element 1 and element 2. Then we will write the percentage or mass. It doesn't matter at this point. Both are gonna work because mass and percentage, they are related to each other, as we've seen in other chapters. Okay, then you write the RAM. Then you do a ratio of percentage divided by RAM, and then you find the simplest ratio. Okay, and we'll be using this in some examples later on. I would like to point out that whereas this is important to be used for the empirical formula for elements, we can also use something similar when it comes to water of crystallization. For example, copper sulfate dot XH2O, we can use the two components, okay, copper sulfate equivalent to element 1, and we can then use the H2O equivalent to element 2. And instead of using the RAM of the element, we would be using the RMM. Okay, you have a question of this sort, you have a couple of questions of this sort when it comes to the questions that you should work after this video. Now, let's work out an example. Okay, so the example is, what is the formula of the oxide when 3.2 grams of sulfur reacts with oxygen to produce 6.4 grams of sulfur oxide? So the elements are sulfur and oxygen. We now have sulfur oxide is equal to 6.4 grams. Sulfur equals 3.2 grams. Therefore, oxygen equals 3.2 grams as well. We subtract from each other. Okay, so we write the mass, which is equal to 3.2 and 3.2. The RAM of both is sulfur is 32 and oxygen is 16. Okay, mass divided by RAM is going to be 0.1 and 0.2, and the ratio is going to be 1:2. The ratio, we do it by dividing the smallest number, okay, dividing the ratio of mass to RAM divisible by the smallest number. Therefore, here we have SO2. Now, we can go on and speak about the molecular formula. So what is the molecular formula? The molecular formula gives the kind and number of atoms. So it doesn't tell you you have carbon, hydrogen, and oxygen. It will tell you you have so many carbons, so many hydrogens, so many oxygens of each element present in a molecular compound. In many cases, the molecular formula is the same as the empirical formula. So in most cases, this will be the case. But in organic compounds, it's very possible that this will change. And the chemical formula will always be the same, will be some integer of the empirical formula. In fact, here we can write an equation relating the empirical formula with the molecular formula. Molecular formula is equal to n times the empirical formula. Okay? So the molecular formula is equal to n times the empirical formula. For the example we had earlier on, for glucose, C6H12O6, we divided everything by 6, and that would be C6H12O6 equals 6 times CH2O. Okay, so let's work out this question. Okay, now this question, a bit of a tip, okay, always start by finding the mass of the unknown. Okay, so we know we have carbon, hydrogen, and oxygen, but we don't know the mass of oxygen. So oxygen is equal to 100 minus carbon minus hydrogen. So it's 100 minus 40 minus 6.71, which is equal to 53.29, I believe. Yes, 53.29%. So we then write the percentage. As we can see, percentage and mass here, they are interchangeable, okay? So it's 40, 6.71, and 53.29. Then we have the RAM. For carbon, it's 12, hydrogen is 1, oxygen is 16. We have the percentage divided by the RAM, where we'll have 3.33, 1.55, sorry, apologies, 6.71, and 3.33, okay? And the simplest ratio will therefore be 1:2:1. So empirical formula is equal to CH2O. And the empirical mass is equal to 12 plus 2 times 1 plus 16, which is equal to 30. As we've seen before, okay? As we've seen before. So this is the last bit, okay? Molecular formula is equal to n times empirical formula, and the formula and the mass are going to be the same thing here. So 180 is equal to n times 30, n equals 6. Therefore, it's going to be CH2O times 6. It will be C6H12O6. Now, let's go and think about a little bit of a harder question, okay? Now, I say harder question. This is something that for A-level is very common to come out, okay? Organic compound A contains carbon, hydrogen, and oxygen only. On complete combustion, 11.63 grams of this compound yields 25.5 grams CO2 and 14 grams H2O. So here, we know we're still going to have to use carbon, hydrogen, and oxygen. But we are not given the amounts of each carbon, the hydrogen, and of the oxygen. Okay? So, we have been given CO2. So, carbon in CO2 is equal to 12 on 44. So, 12 is the mass of carbon, and 44 is the mass of CO2. Times 25.5. which is equal to 6.95 grams. So we will have 6.95 grams of carbon. Okay, for hydrogen, we do the same. Hydrogen in H2O, where we're going to have 2/18. Now remember, you have two hydrogens in water. Each hydrogen has a mass of 1. Therefore, it's 2/18 times 14, which is equal to 1.55 grams. Okay, so that is the mass of hydrogen. Okay, for oxygen, okay, is equal to mass compound minus carbon minus hydrogen. So this will be 11.63 minus 6.95 minus 1.55, which is equal to 3.13 grams. So here you will have the first indication that you are on the right track. Okay, so these are always few hints where just check that you are on the right track simply by ensuring that you have a number which is smaller, which is bigger than 0. Okay, if you get a negative number here, you would know you've made a mistake. So mass of carbon is equal to 6.95, mass of hydrogen is equal to 1.55, and the mass of oxygen is equal to 3.13. Okay, now the RAM is going to be 12, 1, 16. Mass divided by the RAM is going to be equal to 0.58, 1.55, and 0.196, and the ratio is equal to 3:8:1. So the empirical formula in this case will be C3H8O. Okay, now I would highly recommend that you continue working a few more questions found on the worksheets found in the link below. And if you have any questions, please don't hesitate to contact me and ask, and I will be very glad to help you. Thank you, and I will see you in the fourth video.